Hello guys, this is Steve Slope, and the project we have done today is called MedLink. So as we know, because of current development of IT and many electronic information are stored in centralized data place, especially in hospitality management, there are many cyber attacks that have been going on. Some statistics of cyber attacks in healthcare industry are: in 2021, 45 million medical records data has been compromised, and 2022, 2020, 30 million data has been compromised, and the graph keeps on increasing, and it's predicted in 2021 more than 57 million medical records are willing to be compromised. And because of this, it's costing more than $300 million for in a distant span of 5 years for medical industry. And 1 out of 30 patients has data has been compromised because of the hacks by cyber industry, and this is according to Accenture Consultancy. In the existing methodology, most of the hospitals or medical institutes take services from third-party vendor or institute IT department. Both techniques rely on a centralized database to keep track of patients' medical history and functional information. The methodology contains a number of vulnerabilities that could allow hackers to steal information from database. And for example, in 2015, just a small DDoS attacks against medical institutes cost 100 million medical records data has been compromised. Our solution is to develop a global centralized account for patients to store the medical information such as medical records, previous appointments, and other information that can be shared across all hospitals. We develop a universal account for patients where information on one patient can be added to all hospitals, and both patients and hospitals can benefit from it. The patients can stop bringing the paperwork physically in physical form in every hospital, and can stop waiting in a very big queues and lines for insurance companies, where with just one click they can share the complete medical history to insurance companies or a particular doctor. In hospitals also, the doctor can just check the complete user's medical history in real time and can be updated instantly. Our solution is substantially less expensive than the current market standards. The unique approach. We take a novel approach of leveraging a IPFS protocol, a decentralized and secure system. Storing the medical records such as PDFs or images takes up a lot of space, which costs hospitals more money than usual. Our approach is to upload the record in IPFS, which are divided into multiple nodes, and which returns a hash value for every record. Our patient in the patient medical record will be retrieved using a particular hash value. For medical records, storing the hash value is much less expensive than storing complete image and PDFs, since the hash value is maximum 32 bits and the PDF can be greater than 10 MB or 15 MB. The feasibility. Since we know there is a the spending of in 2024 is expected to spend $5.4 billion to be spent on medical institutions, and it is increasing rapidly with a growth rate of 14.3% as an average. And as we know, soon the Web3 is going to be the next wave of technology. This project can be some starting steps of usage of blockchain in medical record industry and medical industry. We believe many hospitals will use this technology for secure storage of medical records to save from many cyber attacks. We as we saw before, the size of the market is more than $2.8 billion, and this way hospitals, doctors, patients can save a lot of time. The impact. This impact of the project can be done in mainly hospitals and patients, insurance companies and patients, storing important medical documents, and many more. The flow diagram. So this is basic flow diagram which we have done till now. So basically there are multiple patients called P1, P2, P3, and for example this I'm showing P1, and there are three medical records called R1, R2, and R3, and the patient one has given permission to doctor 1, doctor 2, and doctor 3. So as the patient has given permission to all the three doctors, all the three records can be shared by doctor 1, doctor 2, and doctor 3. And once patient has removed permission for doctor 1, the records cannot be shown to doctor 1. So this is a basic flow diagram which I've done till now. And the proposed architecture is: the patient has two features. One is as soon as a patient's login, he can give permission to doctor where he can enter the doctor's particular address, or just click on doctor's name, and the complete medical history can be shared to a particular doctor. The second feature is uploading document to the application. Once the patient's uploaded some number of documents in the application, the file is uploaded to IPFS, and the hash value is written, and that particular hash value is stored in the patient's block. In this way, the patient architecture has been done. And coming to the doctor's interface, as soon as the doctor's login, he'll get a list of patients who have given permission to see the medical records. And once you click on the particular patient, all the records have been fetched, and once you click on the particular record, the data can be seen. So this is the proposed doctor's interface. And the tech stack uses Ganache, React.js for front-end, Solidity for back-end, Mojacha for testing Solidity, MetaMask for authentication authorization, Material UI for designs. So this is a future flow diagram where many hospitals and insurance companies can leverage using this project. Where as soon as the hospitals uploads document, the patient can just with one click can give access to any number of hospitals, insurance companies, and doctors. They can be two things: permissions for adding permission and viewing permission, where hospitals are given adding permission and insurance companies are given viewing permission. This is the future flow diagram which I'm thinking to implement at the end. So coming to the implementation of the project. So as I said before, I'm using MetaMask. So MetaMask is used for authentication and login. So for testing purposes, I've already created a few testing accounts. So let me just go through the patient's interface. So as soon as I click on patient interface, since I already signed up, you can see welcome back Ritik, where Ritik is a patient's name. As I said before, you can give the patient two features. One is giving permission, and second is upload new records. Once you click on upload new records, the patient can just enter the record name and choose a file and click on upload, and the particular document is stored in blockchain. So let me show you a demo. Let's say. Blood pressure. Okay, I'm now uploading a blood pressure report, and once I click on upload, it will go to IPFS, and that is stored in IPFS, and in return I'll get a hash value. So for this, the transaction is going to happen, and once I click on confirm, as you can see, the blood pressure report has been updated on this particular day with a particular record IPFS. So in this way, you can upload any number of records in the blockchain, and which is very secure because of using IPFS protocol. going back again, so again, when this one feature, and second feature is giving permission to particular doctor or hospital or insurance companies. As soon as you click on give permission, you can see list of doctors or insurance companies for whom we can to give access. For example, there are many doctors called Dr. Krishna, Dr. Rakesh, and Dr. Ria, Dr. Ramesh, and some insurance companies. Let me give permission for a particular doctor called Dr. Krishna. Once I click on give permission, because of smart contracts on the background, it asks us to confirm. And once you click on confirm, so as you can see, Dr. Krishna is added to the permission list, and Dr. Krishna can see complete medical history. And the same way you can give for insurance companies also. If you're interested to give your medical history for a particular insurance companies, instead of standing in one bigger and larger queue, just click on confirm, and the insurance company also will be given permission to here. Like you can see, Bajaj Life Insurance has given permission to view your medical records. So coming to the doctor's interface, this is the features of patients, and let me move on to doctor's interface. So now I'll log in through a doctor interface called Doctor One, and as soon as I click on login, so you can see Dr. Krishna can be seen, and once I click on view patients, the doctor can see all the patients who have given permission. Right now, just only Ritvik has given permission to this particular doctor, and many patients can give permission, and the table gets increased. And once you click on view, you can see all the medical records which are uploaded by the particular patient called Ritvik. So this is one file called blood picture, and another file for code RT-PCR. And as I click on the button, you can see this is the blood picture record which the patient has uploaded, and you can see the complete blood picture. And the second one is a code RT-PCR report. The code RT-PCR report of this particular patient. So in this way, you can store the medical records in a very secure way, and can be very less vulnerable rather than in traditional methods. The same way for insurance companies also, with just one click, they can see all the patients' records. Just I log in through the insurance company phase, and once I click on view patients, you can see the same thing, Ritvik, and they can see a large number of customers who have given the access, and the same way they can also see the medical records. So in this way, multiple patients can give permission to n number of doctors and n number of insurance companies. So in this way, I have created a very secure place for storing medical records, and very less vulnerable to many cyber attacks. So thank you for giving this wonderful opportunity.